This is Oliver, K6OLI. I'm the District Emergency Coordinator for LAX Northeast, which is based in Los Angeles, the ARES Los Angeles Northeast District. And it is my great joy and privilege to introduce Orv W6BI. And welcome him back to LAX Northeast. We've had some fun talks before, but Orv, and I think it's fair to say, is the heart and soul of AREDN Mesh in Southern California. And he represents the AREDN organization, and he is the expert. Orv's background is as a network engineer and manager for a large hospital network here in Southern California. So he knows what he's talking about, both from the commercial side of things and also from the radio side of things. So without further ado, thank you very much, Orv, for making the time today and walking us through the updates and the latest on AREDN Mesh. Please go ahead.
Oh, thank you, Oliver. I'm flattered beyond belief. Heart and soul, I just consider that I'm going around pimping AREDN software, but I'm happy to do it. And by the way, thanks to you and ARES LAX for allowing me to extend the invite to other folks. It beats the old school driving around and giving presentations to a dozen people at a time. With that being said, let me see if I can successfully make things work here. Let's see. How's that, Trons? Look okay?
Looks great, Orv. Thanks.
Excellent. Just a quick explanation. This was originally designed for LAX Northeast here in Southern California. So at the end, there is some location-specific information, but we can use it as a teaching moment because it pretty much generally applies to anybody who's making a network. So over the last, actually all of this year, AREDN has launched into a first phase of a number of projects that are impacting the software, even though at first glance it looks the same. And we'll talk about what the latest release looks like, because it started out as one simple task, and as they went through it, they kept adding little tweaks and peaks. So the biggest one, the original AREDN code, which they inherited from Broadband Hamnet, the web pages and the supporting libraries behind them were written in Perl. Works fine, but the Perl libraries are really large. They're way overkill for a little embedded project like this. So the first phase of the project was to convert all of those web pages to a lighter weight language intended for embedded devices like the AREDN gear, and that's called Lua, and I forget what it means. And there's a nice explanation for it in Wikipedia. There's a nice explanation for everything in Wikipedia. So if you see a phrase in here that you don't understand, chances are good you can find a nice description of it in Wikipedia. So anyway, by the way, just a little background. Last year, middle of last year, a software programmer up in the Bay Area became interested in AREDN networking and decided he'd like to contribute. So he got his license in June of last year and committed his first major patch in October. That is Tim, KN6PLV. He lives in Berkeley. Wonderful guy, smart as hell, knows 6 or 7 programming languages, and he did the bulk of the heavy lifting in this conversion. Because they recovered so much space in the Flash by dumping the Perl libraries, they decided to take the opportunity to embed the tunnel client and server into the code. They're not loadable modules anymore. Now, if you're just running a tunnel client with one tunnel open, that's not such a big deal to disable the tunnel, upgrade the code, reinstall a new tunnel module, and then re-enable the tunnel. But if you're running a tunnel server with 12 to 15 tunnels active, it's a very big, cumbersome deal, and you can't remotely upgrade a tunnel. So with them installed, it's much, much more straightforward. You don't even have to disable the tunnel. It'll come back up after the upgrade, after you've installed this code. Because they've compacted and rearranged stuff, and there's more space both in RAM and flash. Future upgrades should be much more reliable. And I can testify to that, having loaded some of the follow-on nightly builds. The success rate, well, it's not 100%, and it never will be because of flaky links, is substantially higher than it used to be. Down at the bottom of, I think it's the basic setup page, you have an opportunity to point to an NTP server. Now the code will come out, go searching for an NTP server if the default one is not reachable. The little asterisk there is to remind me that if you run an NTP server out there, the requirements for advertising that NTP server are a little more specific to allow it to find it automatically. And those guidelines, and they're not hard, are in the latest documents. So if you run an NTP server, skim through the documents and make sure you're advertising it in such a way so that all of the new nodes can find it. A guy I know, K6CCC, Jim, runs an NTP server. And after he fixed it, within an hour, a dozen or so nodes had latched onto his NTP server. Excuse me. The default VLAN is -2 for the WAN port. Under certain conditions, it's handy to be able to change it. We had custom coded this out in Ventura County a couple of years ago. And after much nagging, they agreed to include it as a default, and other groups have found it useful. Iperf is a performance testing tool. We're now on version 3. Used to be a loadable module, and then you had to either use it via the command line or put Iperf speed on top of it to run performance tests. These are true throughput tests. The TX Mbps that we've all seen is not a throughput. It's not a true throughput number. It is the modulation rate times the packet completion rate. And unless you're running a fair amount of data, it's not correct, and it is not a throughput tool. But they included Iperf3, plus they added a simple web UI, and I'll go into that later. So really, in my point of view, there's no reason to load Iperf speed anymore. It's pretty slick and has been very revealing as we've used it. If you've ever renamed a node, you found that both the old node name and the new node name hang out there until you shut the node down for a number of minutes. The new software is smarter. It notices that, and it will drop the old node name and any services advertised by it. Tim said approximately 30 minutes. That's good. Oh, and you know, it's always been a bit of a hassle to figure out which firmware to load, because the same named firmware is used on a number of different pieces of hardware, and it's always by guess and by gosh. So now they pull the hardware branded model out of the firmware and advertise it on the main page, and I'll point that out later. But wait, there's more. And by the way, over and above what I'm showing you here, there's another handful of back-end stuff I decided not to talk about. I was afraid it would take too long, and some of them are relatively minor and only affect internal operations. So anyway, the next big thing that Tim added to the code over and above the Lua conversion was something he called link quality management. He's up in the Bay Area, and their network is not nearly as organized as ours is down here. They threw a bunch of stuff up on the air without a lot of frequency coordination. They're working on establishing some backbones, but it's a work in progress. So Tim discovered that his link throughput to a remote site was abysmal, and set about investigating it, discovered some root causes, and he applied some fixes. And he persuaded the AREDN team to include it. We did a fair amount of testing and nightly builds, and it was included in the production release. And I will say that after the production release, we didn't find errors, but we found places where it could work a little better, and the follow-on nightly builds continue to improve on that. So if you're going to launch into this, I recommend running the latest nightly build and enabling LQM. So anyway, if LQM finds really crummy links that have really bad SNRs, signal and noise ratios, too far away, or low quality. Low quality means you have a lot of retransmissions, and we have a limited number of bandwidths, so we really want to limit unnecessary use of that bandwidth. And it uses the distance to optimize the transmission rate and timing of the link. They are customizable because it turns out a lot of people have been depending on really crummy links, and the defaults will chop them off, so you can fine-tune them. If you just straight install it, it's turned off by default, but if it was previously enabled by a nightly build, it will continue to be enabled. Also, it depends on the latitude and longitude of both ends of a link to calculate the distance. So it's become more important, even more important, to include latitude and longitude. Okay, here's some location-specific stuff, but as I said, it would apply to everybody. Here's the network in Southern and Central California. We're now including Central California because I gave a presentation to those folks up there, I don't know, 4 or 5 months ago. Kind of lit a fire under them because they'd always wanted to get started but never found any traction. And turns out half a dozen or so of them up there are WSP technicians who have access to mountaintops, so they threw up some stuff in quick order. Currently, a lot of their stuff is tunneled, but they're in the process, literally as we speak, of establishing RF links. And just for the people on the West Coast, we've established hilltops that perhaps next spring will allow us to link the Bay Area to Southern California. Now, that's not necessary for emergency management and emergency communications, but it's part of the hobby and it's fun. So anyway, if you haven't seen one of these maps before, this is this particular one is written by KG6WXC Eric out here in Port Hueneme, California, up along the coast. It goes out and crawls the network, and within each node, there's used to be a text file, now it's a JSON file of all the vital data about that node: hardware version, software version, hardware type, latitude and longitude, version of the software, I said that, and all other sorts of vital data, including link qualities. So if the latitude, and he goes out and maps those and pulls them into a database, and if the latitude and longitude are loaded, he can display them on the map. On this map, orange is 5 gigs, purple is 3 gigs, or 2 gigs, blue is 3 gigs. I forget what color 900 is. We don't hardly have any use. And you'll see some gray ones on the map. Those are maps, those are nodes with no RF link. Typically that would be a HAP AC in somebody's shack. I have admin rights to this database, so I downloaded a CSV the other day, and I actually sorted out and counted those nodes, and there are 495 nodes visible on that map. So anyway, you'll hear people occasionally refer to the LA basin, and this is approximately how big it is. And LAX area northeast is somewhere in the middle of this, approximately. And depending on how much, the definitions of the LA basin vary a bit, but you're looking at somewhere between 1,500 and 1,700 square miles. That's a lot of area to cover. We started pushing out a network in Ventura County in 2015, 2016. And for whatever reason, LA County, which you're looking at here, my county, Ventura County, is off the page to the left about, I don't know, a couple of screens. For whatever reason, LA Basin was very slow to get started with mesh. So we extended the network to Verdugo Peak. John, can you see my cursor?
Yeah, if you slow down a little bit, we'll be able to follow a little bit easier. So
Okay.
you're in near Burbank right now.
Right.
Yep.
There's a peak here called Verdugo Peak, and we linked from Ventura County in here. And a while later, we had the opportunity to extend the backbone over here to a mountain called Mount Wilson. It's at 5,700 feet. I think it's actually above Azusa. But at any rate, it has a wide view of this area. Now, you can see the node here up at the top center. There's actually a couple, one pointing northwest and one pointing northeast. And we knew at the time that it was not the optimum place for a node, but we thought to stimulate some activity, we'd put them up there. Since then, we've been looking for ways to improve it, and those efforts have not proceeded, and I'll talk about that. One of the reasons Mount Wilson is so challenging is RF. This is a picture of Mount Wilson. It's fairly old. There's probably more radiators up there now. I don't know if it's still in effect or not. When you're operating around a nuclear power plant, if the radiation is high enough, they'll mark it as an 8-hour per day a site. In other words, you're limited that amount of time per day. The RF density got so bad up here about 20 years ago, they had to mark it as a 8-hour per day, and the rangers could no longer stay up there overnight. The other problem is, I'm going to talk at length. You like my graphics of the mountain? So anyway, obviously closer links will be stronger, your intermediate ones will be weaker, and you've got the ones way out there. If the node on Mount Wilson has to talk to all of these, it has to modify its timing to accommodate all of them. So it slows down inks and acts to wait for responses from the farthest node, which means it's unnecessarily slow for the closer in nodes. Additionally, most likely the farthest nodes out will have the most retransmissions, and they will take up an unnecessarily large percentage of your available bandwidth. So this is not how you do it. We knew it wasn't right, but we thought we'd fix it, and we haven't. Here's the really right way to do it. Since we established on Mount Wilson, Oliver, we've been sort of kind of looking around for intermediate level sites like Puente Hills, the Whittier Hills, stuff like that, to establish lower cells, and those cells could communicate amongst themselves. But from that area, I'm 75 miles away, and it's kind of hard to coordinate it. So I've been hoping that some people would start establishing local cells. I think the group in Whittier is working on that with some served agencies to a local hill, and they were going to link back, but I haven't seen that yet. So what happens is, now that we've got LQM, if some hill there happens to have somebody link in from a distance away, and the assumption is they've got a closer hill off to the right of the screen they could be linking to, you could tell LQM to chop it off and not bother them, and it will shorten its timing up to the shorter nodes, closer in nodes, and you can improve your performance. So here's the deal. Back in the old days of packet 1200 baud, the latency was so high that you wanted to minimize your hops because it took forever to retransmit. So you had long links, fewer long links. It's the exact opposite with mesh networking. The throughput can be so high that the additional latency for repeated hops is not that bad. So you really want to concentrate on more shorter hops. The downside is more hardware involved in the network, but it's a good trade-off if you want higher throughput. So anyway, on the advanced configuration page down at the bottom, you'll now see an LQM switch. If it's off, you won't see all of these options. If you click it to on, save settings, and reboot, you'll see all of these. I'm not sure if these are the default numbers or not. I think they're pretty close, but I've been doing a lot of tweaking during beta testing and nightly builds, but you'll see these here, and I would say start with the defaults. Once you reboot, you'll see this neighbor status, or it will appear. This model number here will be here all the time. I just wanted to highlight it and make sure that you notice that you now know what hardware you're operating on. So neighbor status originally started out as only RF neighbor, but Tim noted that he could, while he doesn't have any RF information on a tunnel or a DTD link, he could in fact measure the quality. So he's included it in the neighbor status. We'll look at that in a bit. Down here on the, this is the basic setup. You've got some new tweaks here. Maximum distance, the default's 50 miles. This is how you chop off those annoying distant nodes that don't need to be on your local network. 15 dB SNR is AREDN's recommended minimal SNR to get 2 or 3 megabits per second throughput. If you're routinely using links that are below 15 dB, you really need to concentrate on improving them, because if they're below that, you're sucking up a lot of bandwidth retransmits. And a minimum quality of 50%, that's a really low bar. If you have LQ and NLQ less than 80, 85% on any node, that link is not very good. A good link should be above 90%. So anyway, those can be adjusted. So this is the neighbor status. This is in my valley. It's a 2,200 foot hill. Most people are less than 6 miles away. This is what you'll see after you go over there after rebooting. LQM will spend about 5 minutes evaluating the links, and during that time, it'll be pending. By the way, I'll mention it later. This is what you see after it's been running for a while. The statuses come up as they should. And you can see this is a very clean network. Everybody's above 90%, good SNRs. This is Mount Wilson, the southwest pointing node. Got some things to talk about here. The one I circled in red, highlighted in red, has been blocked due to the signal. Notice the SNR is 7. Didn't make the cut, which is fine because K6CRW, Steve, is in Culver City, way out by the coast, and it turns out that their local LAN, their cell, is on the same channel as Mount Wilson Southwest, and he happens to be in a position to see it. Well, I've cut him off so he doesn't try and talk to it, and so Mount Wilson doesn't try and talk to him. He's got other access methods. However, that's kind of a moot point, because if you'll notice, NG6R Jerry is 34.2 miles away with a good solid signal. And normally I wouldn't allow it, but because he's providing a vital service, he has a dish up on Palos Verdes. For those of you who aren't aware of it, the LA basin is flat, but Palos Verdes sticks up out of that flat area right against the ocean, and they have a good view of the southwestern basin. So he has a dish antenna linking to Mount Wilson, and then he has a sector antenna providing service for local people. So he's got a local cell, but the problem is he doesn't have a dedicated backbone link closer to connect to. That's something that needs to get fixed, because everybody in here, even K6ECG, 0.3 miles away, Mount Wilson has to run at the same slower timing as it does NG6R because he's the slowest one, and they have to accommodate the slowest one. If he didn't, AX would time out. They wouldn't wait long enough to get an answer back, and that's because the speed of light is so slow. So I talked about the built-in throughput test. There's 2 components: a sender, which when it's asked to, will send data packets absolutely as fast as possible, far faster than any application could. This is to stress the network link. And the Iperf3 receiver will request that, receive all of those packets, acknowledge them, and record the metrics, and it runs 10 passes, I think, and then finishes. And there's nothing left to be done. The sender will shut off. So it's really pretty sweet. And it's really easy to use. You open a new browser tab, and this is the generic format of what you put in there. I never can remember it. I have to copy and paste it. This is the receiver node name, CGIB and iperf question mark, the server, the node you want it to test against, and then the protocol. And here's an example of me testing my node, W6BI-VC-QTH-5G is a power beam up about 35 foot on the mast, pointing at the server, which is K6 PVR VC CME East 5G, which is up on Chatsworth Peak about 6 miles away. You'll notice I didn't call out the protocol. You could specify TCP or UDP. UDP will run faster, but it's kind of a moot point because AREDN uses all TCP. So just leave it off and run the default. So you can run this and get results. And then I recommend you run it the other direction, because frequently this will uncover unidirectional problems. Like if you have excessive noise near your access link on a hilltop or something, you'll see a slower rate. So here's what comes back in that server tab. You can see it ran 1, 2, 3, 4, 5, 6, 7, 8, 9, yeah, 10 runs, and then averaged them all out. And you can see down at the bottom, the bit rate is around 15 megabits per second, which is not too shabby. I think that's about as fast as mine will run. From time to time when I run this, the retries, the column of 0, 0 is not 0. It was about 50 each, and the bit rate was significantly slower. That comes and goes. I think we have an interference problem occasionally on Chatsworth Peak, and that will have to be investigated. Then you would open up another tab and run it the other direction and compare the two. It's a really handy tool. And you need to have at least the latest production release, or this was implemented a few nightly builds earlier than that. But obviously both ends have to have this facility. And by the way, it doesn't have to be single hop. You can run it to a destination 3 or 4 hops away, and you'll be flabbergasted how poor the throughput can be if you've got a weak link. Also, it doesn't have to involve RF. I ran it between my shack and the node on the tower and found an abysmally slow rate. I have a defective network switch in between. So that's on order, back ordered. So it's useful to run it various places that you use a lot. Highly recommended. It's cheap entertainment at any rate. So what's coming up? You've heard talk about support for 802.11 AC devices. I'll talk briefly about that. And a new user interface, and I'll talk about that. So 802.11 AC is the follow-on to the 802.11n protocol. Substantially faster, some other improvements, but we're not doing it for higher performance. 802.11 AC's claim to higher throughputs is due primarily to the fact that they can accommodate 40 megahertz and 80 megahertz wide channels, and that ain't going to happen on ham radio. There is one modulation scheme added to it that we can take advantage to running it on 20, 10, or 5 megahertz channels, incrementally slightly higher throughput, but only on really stomp crunch strong SNRs, really high, strong signals. The reason AREDN is moving support these, all of the vendors are upgrading their chipsets to chips that support 802.11 AC, 802.11n, and some of the older protocols. But the driver is different, so the software has to accommodate it. OpenWRT is supporting all of those 802.11 AC devices. And if you didn't know, OpenWRT is what AREDN software is derived from. And they support it just fine, but only on 20 megahertz wide devices. The requirement for 10 and 5 megahertz wide channels isn't part of their requirement. AREDN has to add it along. and they've depended on one or more other developers to finish those drivers, because driver development is a highly specialized software skill, and AREDN doesn't have quite the skill set yet to do that. So they're waiting on them for various reasons. That's not happening. They're working on pushing it forward, but I'm guessing, this is not AREDN's guess, I'm guessing second quarter of next year before we'll see that support in nightly builds. The next generation user interface, the interface we've been using started with broadband hamnet over a year ago, or over a decade ago. They're moving to something that's more modern looking and looks looks like it wasn't done in the 2000s. Plus a modern API. This one they'll be able to add and remove features to the API. And if you don't know what an API is, it's an applications programming interface. This is how an application makes calls to the OS and gets information back, specific information. And it's all JavaScript, Vue.js, nuxt.js, and Vuetify, which I guess is a play on Beautify. But all of these allow them to very flexibly create a new user interface. The cool part about it is the JavaScript, first time you come to a node that's supporting it, will download to your browser, and from then on, you don't need to load it again. From then on, only thing that loads when you reload is the page data, TXM, BPS, not the whole UI, not the whole page UI, just the data. So it should be much smaller data transfers and much faster resulting page loads. Good news, they've had one programmer chipping away at this for, geez, I don't know, 18 months now, and they only recently added 2 new programmers, and they're starting to come up to speed on the code and the tools. So maybe we'll see something, in a few months. So here's some screenshots. I'm not sure if this is prototype code or just something he threw together. This is in dark mode. He chose to do screenshots in dark mode. I wouldn't run it, but that's okay. And this is the local hosts, and it's just running on a test hap. These are current neighbors here. Here are remote nodes. And you can see he's advertising some services here. This is the basic info. You can see it's laid out differently. I'll point out one thing. You'll notice down at the bottom, radio number 0 and radio number 1. A lot of the new hardware has the ability to plug a second radio in the chassis. And the software could be 2 5 gigs, I don't know, or a 5 gig and a 2 gig, or who knows, 5 gig and 11 gig, or 5 gig and 60 gig. But the point is, there's a slot there, and you can plug in a radio. I think it's a PCI slot actually, and bring a antenna connector or connectors out, and then the software has to deal with it. So this is how the interface looks. The next OpenWRT, I believe, accommodates multiple radios, and so this is AREDN's first pass at how they're going to accommodate those. I have no clue how that's going to work. Okay, this is the setup, basic setup. Things are laid out differently, but you can see where they are. Want to point out one thing. Notice this drop down here that says active node. If you hit it, you can go to another node and pull up its data just by going to there. And the only thing it changes is the data. It doesn't have to reload the UI. That's assuming these are all running the new UI. The developer wasn't sure yet how they're going to handle if you go from a new UI node to an old UI node, what they'll do. Obviously they can't, I don't think they can pull the code out of an old UI because it'll send the whole page. So they'll probably just revert to the old UI or a warning or something. That's still TBD. So if you load the latest nightly and you do a Wi-Fi scan, you'll see this new thing down at the bottom, a spectral view. This is a work in progress, fun to look at. You can get some basic data out of it, but here's the deal. OpenWRT never anticipated their code running on the channels we're running and the narrow bandwidths we're running. So the spectral view API is going to need some more interpretation, and they're actively discussing how to better accommodate this. This is just a work in progress, fun to look at. And you'll, as you go along and load the nightly builds, you'll see it will probably change over the next few nightly builds, but just thought I'd throw that in there.
Hey, Orv, could you, oh, actually, I was just going to say there's a question in the chat. So let me take Brett's question first. In chat, he says, we have a lot of users who are reluctant to upgrade to new releases. The old idea, don't fix it. If it's working, what happens when the old firmware and the new are on the same mesh?
Let me talk about that. Oh, hang on a second here. The old firmware will talk to the new firmware just fine. Let me think if there's any caveats about that. You don't need LQM on both ends of a link to improve the link. It's all about the node's personal survival. It'll make that node work better even if the others are running really, really old hardware. It may not be broke, but you're kind of running a 1971 Ford Fairlane, you know? Why would you want to when you can get a new one for free? The other thing I want to talk about is it's increasingly less of a problem here as time goes on. But we run MIMO devices, you know, the multiple input, multiple output, dual polarization, because they can send a data stream both directions and they combine it at the other end for twice the throughput, or 3 dB better. If it's 3 dB down, you'll get the same throughput as a non-MIMO device. The problem is it's not quite like water and oil, but MIMO devices don't work very well with non-MIMOs. If it's got an end connector on it, it's not MIMO. A single end connector, like a bullet, and some of the old maybe air grids or something like that, you're wasting half your power. So as you can, pull those ancient devices off and really try and get your software upgraded, because over the years they've added improvements. Some of the old gear was old software was really tough to upgrade. It's increasingly better. So I would encourage everybody to upgrade.
Yeah, and I understand it's actually quicker, easier to do. We've got a question from Tom, KN6BKT. Go ahead, Tom.
Hey, Orv. So I'm one of the guys that has the real shaky connections up to Mount Wilson. I'm shooting a gap between my neighbor's big old house and a big old tree. So like, you know, my LQ is like pretty good. It's in the high 90s, but my NLQ is in the toilet, in the 20%. So and I want to be a good neighbor, obviously. Would I be better off using LQM and fiddling with the values, the SNR values, or turning it off?
Well, you can turn it on and off and experiment. That NLQ being very poor, that's a result of all those transmitters up on Mount Wilson. It's having trouble hearing things. That's why we really need to get some lower, closer nodes and cells up there. I had to drop the default values on Mount Wilson a lot to let some of those nodes continue communicating with it. So it's not a very good arrangement. I'm sorry about that, but it's all we had at the time.
Yeah. Okay.
Yeah. So
thanks.
Yeah, experiment with it.
Okay.
Bring Jeff to the front too, who has a question. Go ahead, Jeff.
Hey, Jeff.
Hi, Orv. Thanks for the conversation here. This is really useful. I have a link to Mount Wilson, as you know, which in my observation since the latest upgrade has deteriorated significantly. although I have about a 29 or 30 dB signal to noise ratio connection, my link qualities and neighbor link qualities are much lower than they used to be. I'm just wondering, is there something at Wilson that's sort of in process of being corrected, or should I start investigating my hardware? That's the first question, and then maybe I'll ask another question, which you can string together. The neighbor link quality, as long as Wilson is running this link quality system, is there any use for me running it on my end? Nobody else connects to me. Is there any advantage to running it on both ends?
If you see other nodes on that channel other than Wilson, then you could try use LQM to drop your node's awareness of them, and that would improve the bandwidth. And by the way, just to clarify, the LQ and NLQ parameters on a node, LQM doesn't have anything to do with those. Those come from the driver. So the software doesn't mess with LQ and NLQ. It just reports them. So I would try running LQM, see if you can stop. If you see any other nodes on the channel, see what you can do to drop them, like, raise your minimum SNR or something, and your node will stop using bandwidth trying to communicate with them, which will preserve your bandwidth going to Wilson.
Okay, I'll check, but I don't think there's any other nodes that are
right.
being seen on my end.
Yeah, like I'm saying, the Mount Wilson is one of my worst examples of how to build a network, but it's what you guys use, and until we get something better, we'll maintain it.
Yeah, I mean, what I'm seeing happening with the node now is it's toggling back and forth between connected, seeing hundreds of nodes, and then 5 seconds later, nothing.
I'll take a look at your node, and I'll if I need to, I'll drop the settings even more on Wilson. Well,
like I said, if it's a hardware problem on my end, I'm happy to deal with it. I'm just not really sure where to look first.
It's probably not. Let's go see. Well, here we got time for a few to discuss this. Oh, we got 15 minutes or so. Let me share my screen again.
Yeah, if we need to go over Orv, then we go over. I think this is a fantastic discussion, and I think everybody benefits from this. So,
okay, let's see. Quit here. By the way, just another hint, and everybody's probably doing it. Everybody has folders up here. This happens to be Firefox. I've got a general ham radio one, and I've got one for HamNet. And things I get to a lot, like all the nodes I get to, I've put here, so I don't have to search them out. And I've got them separated into tunnel servers and my local nodes and some utilities, cameras, stuff like that. If you're not doing something like that and you do a lot of stuff with individual nodes, this might be handy. But Wilson isn't one of them. So I'm going to search for Wilson. Here's the Southwest node. See if I can get to it. My link is flaky.
Just explain what Orv did there. He used the Control F as in Foxtrot command, and he just searched the entire page for Wilson, and that brought it right up.
Eventually.
Yeah.
There we
Orv,
go.
could I ask a favor, and could you just kind of zoom in again, Control plus or something, just so that we can see the text?
Yes, I will. I meant to do that earlier.
No worries. Thanks.
How's that?
Excellent. A little bit more if you wouldn't mind.
Wow.
A wee bit more. You got some real estate. There you go. Thank you.
Okay, so here's Wilson. Let's look at its neighbor status. Here's Jeff, 30 dB. This is actually a good signal, Jeff. 79% idle.
Yeah, but see, I'm showing on my end, the neighbor link is 16%, 1.6.
Well, let's go back and look at mesh status. You'll notice this occasionally. This crept up someplace if you refresh, it has something to do with the timing of the OLSR daemon. This is 3 or 4 hops away. And hopefully we'll get something here. This may be a short demo. Yeah, we lost the 3 gigahertz link between Verdugo and Wilson, so we're bridging it around it with a tunnel for now. Trying to figure out a good link. Oh, see, there you go. Try again.
Yeah.
So there we go. Well, come on. Oh, look at that. It's not hearing these well enough.
Yeah, so that's me down there, 1073, 131. And you can see that the neighbor link on that was like 2%. So
yeah,
what I don't understand is why that number keeps bouncing around. Prior to this last release, I was getting neighbor link quality on the order of 80% almost routinely. And now it just barely ever gets above 20. So again, I don't know if it's a hardware problem, I'd like to solve it. But if there's something else, it may go beyond my experience.
which one is yours?
1073, 131.
Yeah, 6% link quality. I wonder if there's more interference up there now than there used to be.
Are there more nodes connecting now? I mean, you roll out a new software and people get excited about it. Are more people trying to get RF connections?
I don't know. I'm back to my local node here. Let me expand it. You can see that, oh, stop it. It's 483 nodes. When we've done our network stress tests, we've stressed somewhere between 600 and 1,500 nodes, and the network itself has handled it fine. During the last couple of stress tests, actually the first one, we did find some software issues, some scaling issues. Those have been resolved to my knowledge. And honestly, there's not a lot of traffic on the network. The OLSR broadcasts are constant and they're getting larger, but they're just text. They're couple, maybe 100 kilobytes per. It's not like anybody's sending HDTV. So I don't think bandwidth is the issue.
So Orf, could you perhaps, kind of demonstrate to us how to run the Iperf speed test on the node for both directions and see what we would see?
I can. Not going to do it to Wilson. Here's a new tab. And I have to go. Oh, that's not what I want. Let me go to the AREDN site.
Yep, and I see Dan K6DLC's hand up too. We'll get to your question in just a moment.
Okay, hi Dan. And I never can remember the format, so you can see I've looked it up before. And it's here. Now let me again increase it. They're using the onboard Iperf URL feature, and it's right here.
So there was a suggestion, maybe, there's a nice nifty button in the new user interface that kind of allows you to choose node or something like that and do the test. If the group is taking feature requests, that is.
You can always put it in a feature request on their GitHub. This is what I have to do because I never can remember it. So let's see. W6BI-VC-TTH-5G. I'm not going to use, I hope that's legible. I can't increase the size of this particular one. K6 PVR VC CME East 5G. Take this and copy it and open a new tab. And let's see if I typed it right. And it takes, I don't know, 5 or 10 seconds to run. See if I'm getting that interference problem. Ooh. No, it looks clean, getting about 15 megabits per second. And, you know, folks, we're used to getting 100, 200 megabits per second on your internet link. At least that's your link. We don't need that much. We're not going to get that much. And you can do a lot with this. I took it out, Oliver, but I had a thing in there talking about WinLink and the difference between moving traffic at 1200 baud and, well, 15 megabits per second. And by the way, I mentioned that the application is typically the bottleneck. In my regular presentation, I talk about testing, moving a piece of WinLink mail to a post office that was 3 hops away on the network. And I timed it and I got 220 kilobits per second. So the bottleneck there is the WinLink software. But the nice part about it was I didn't have to specify digipeats or hops or anything like that. The network knew how to do it. So WinLink and the mesh network were made for each other. So if you're running WinLink and you're not on the mesh network, you really seriously need to consider it. It's not that hard. Any other questions?
Daniel, K6 DLC, I think. Go ahead with your question from Redwood City.
Oh, hi, Orv. It's been a while since talked to each other. Couple of things. This is the basic level. I'm starting seeing people who are so-called becoming expert on WinLink. That they're telling new users to use that website to find out your distance between point A and point B. The reason why I bring that up there is that website is a good website. However, and I have an example here. I have a mesh node that's roughly 7 blocks from me. I get with SNR number like 2 or 3 with that one person. However, I got another mesh node that's about 1.5 miles from me, and I'm looking at about maybe 15 with him. The difference is that don't rely on that website to tell distance A to B, because the one person next to me, we've got 3 redwood trees that are blocking the path, and people don't even consider things like that. I mean, that map does not tell you how many redwood trees or how many new construction you have. It's just a general thing. It's a reference. But I'm just tired of people, relying on that 100%.
They need to get educated. This stuff is line of sight.
Well, I know, but people don't realize that 5 gigahertz with the redwood trees doesn't go through very well.
Nope. It's an evergreen. You'll never get improved. It'll never improve. Yeah. Just point out to them that it's true LOS. It doesn't even do knife edge stuff like 2 meter FM does.
Right, but the thing about it that these people who are convincing other people are the people who know how to articulate on words. That they can be you, or and you can convince the world. Use that as your reliable sources, and people will listen to you. For example, I'm not saying people listen to you 100%, but
well, Dan, if you've got a local group up there that needs a presentation and needs to get educated, I'm happy to do it.
Oh, we got the San Francisco group here that they're pretty good. So
they are.
But we're getting new people on there who are taking the action of becoming experts. And I've been doing this for years, and I go, I'm just going to keep my mouth shut and let them fall in the pit, as I say.
Well, those sort of problems tend to be self-correcting. If it doesn't work, they'll find a way to make it work, and lo and behold, that'll be a better path.
Okay, now the new version of AREDN, is you say it gotten smaller? Are they handling the small devices like the previous version of Mesh, the AREDN could not support? Are they handling those, or are they just kind of ignoring those small devices that have less memory?
Let's put it this way: they're all still supported. The software is smaller, so it's easier to load in the older 32 megabyte devices. So yeah, you can use them for a while longer.
Okay. And that's all. I'll talk to you later privately. And Oliver, you want to say something?
Well, thank you so much, Daniel, for the questions. And let me do one more question out there. Is there anybody who's got any final questions for Orv before we thank him very much for his talk?
Yeah, I see one in the chat channel from Brett from Oregon. He's asking about, is the 3226.0 ready for install on a widespread basis, or is another maintenance release planned? Here's how it works. They put out periodic production releases. It varies widely. Oh, thank you. Varies widely between annually and semi-annually, depending on what's going on. And those production releases are fine. In between, as they find minor bugs, implement minor enhancements, add new products, they come out with a nightly release, and it's not nightly. The process to build runs nightly, but if there's not been any code changes submitted, the nightly doesn't run. So those come out on a very irregular basis. Since this last production release had so many significant improvements, subsequent to releasing the production release, they're finding little tweaks and peaks. And Tim's a coding fool, and he's been putting out improvements since some of it's been with his code. And I was going to mention, if you put in 3226 and you don't see something you saw in my slides, it's probably because it was implemented on a follow-on nightly release. And the nightly releases are really, really minor. I wouldn't hesitate to recommend to anybody to stay up on a nightly build periodically. Let's see, I've been testing nightly builds for 5 or 6 years ago. I've only had one they put out that they had to yank back immediately. So that's a pretty good record. So yeah, I always install a nightly build. If it's a new build, a new piece of hardware, I'll put the nightly build on it.
I couldn't agree more. I have to say this this latest release has been really easy to update, and I've never had it. And I've updated 12 of our nodes here, and it just was the easiest to do. And so I highly recommend that if you get a chance. And so, all right, let's take one more question from Dan, WL7CO, and then Dan, come on right up.
Orv, is the W6BI Vera HF gateway getting to the cloud via AREDN?
Yes.
Okay, great, thank you. And an indelicate comment, I'm fairly sure there's nobody else in our age peer group who's as successfully pimping anything as you are with regard to AREDN. And
I'll take that as a compliment.
And have been for a half a decade at least.
I may have missed my true calling.
Yeah.
No, I think you're well ensconced in it. And I can't tell you how much I appreciate it.
No, you're very welcome. I enjoyed this stuff.
And it shows. And Orv, I do want to say thank you so much for taking the time. And this was, I feel a little bit like Neo from The Matrix, right? I know Kung Fu. It really feels like a download today. So thank you so much for taking the time and making it really approachable and fun, and walking us through and giving us some hands-on example. While you were talking there earlier, I actually tried it out on the K6YZF node and did the Iperf3 works brilliantly. And that's, I think, always the takeaway from any great talk. It gives you something you can try out almost immediately. And I think that's extremely satisfying. So thank you so much, Orv. Everybody, a big hand for Orv. We really, really appreciate it. Looking forward to having you back next time. And
anytime.
we'll continue that conversation about putting up local nodes. Now that we get access back to the local hospitals, we know some of them are interested in providing these services. And so we're looking forward to that. And with that, I do want to point out, we'll take a 5-minute break. For those of you who want to stick around afterwards, we'll talk really quickly about WinLink Telnet. That's going to be 5-10 minutes. And then we're going to do the Aries LAX Northeast business, and I'll try to get everybody out of here by 11. All right. So again, thank you so much, Orv, and feel free to stick around, or feel free to release. And everybody, go grab yourself a coffee right now.